Hello and welcome to today's webinar. We are going to be talking about the exciting new features in the recently released nRF Connect SDK version 2.3.0. So I will be your host for today's webinar. My name is Tiago Montt, and I am a developer marketing manager at Nordic Semiconductor. So before we get started, a few practicalities. The webinar will have a duration of approximately 50 minutes, followed by about 10 minutes Q&A. We, of course, encourage you to ask questions. And if you do, please type the questions on the top right sidebar. All the questions that you ask are anonymous, and please try to keep them relevant to the topics that we are discussing during the webinar. We will address those questions during the Q&A at the end. There's also a chat functionality in the bottom right sidebar. That one is not anonymous, and we ask that you do not use the chat for questions. So keep them in the top right. And after the webinar, if you have more questions or if your questions are not addressed during the Q&A, you can always go to DevZone and get further support from our tech support team for any additional questions you may have. We will make a recording of the webinar available, and that will include both the morning and the evening Q&A sessions. And you can also then download a copy of the presentation. If you go to this link down here, you'll find the webinar on demand in the coming days. So let's look through the agenda quickly. So we'll have first the intro to the nRF Connect SDK. Then we'll have updates on development tools, and that includes a demo. We'll have updates on Bluetooth, updates on Wi-Fi, also including a demo of the recently launched nRF 7002 Wi-Fi 6 companion IC. We'll have updates on Matter, also with a demo, and we'll close with updates on Cellular IoT and then the Q&A. So at Nordic, we have an important mission also of exciting and supporting developers. And we have different vehicles in which we try to engage with developers and keep them supported throughout their whole application development cycle. So the webinars are mostly used for technology intros and some trainings. Then we have the Dev Zone. So when you have a need for reaching out to our tech support, this is the place to go. And there's also, of course, a lot of interaction between different customers supporting themselves, which is great, forming a really powerful online community. We have a presence on GitHub. The nRF Connect SDK itself is hosted there. So you'll find a lot of an extensive code base on our GitHub project. And one of our newest initiatives, one of our newest platforms is Dev Academy. So this is an interactive online learning platform, and it gives you step-by-step courses on different topics. So currently we have available a nRF SDK fundamentals course, as well as Cellular IoT fundamentals course. But of course, we will roll out new courses over time on other topics. So let's have a quick intro to the nRF Connect SDK. So what the nRF Connect SDK is, it's a unified code base and toolchain that supports all of our products from the nRF 91, 70 series, 53, and 52, as well as 21 series. For nRF 52 series, it's optional. So it started, support was introduced in version 1.3.0 of nRF Connect SDK. But we strongly recommend that if you're doing a new design with the nRF 52 series, you do go with nRF Connect SDK. And the reason is that the nRF 5 SDK is in maintenance mode. It is Bluetooth 5.0 qualified, but we're not introducing any new features into that SDK. So if you are starting a new design, you will want to go with a future-proof solution, and that will be the nRF Connect SDK. So this is the one that we're actively developing with these more or less quarterly releases with new features, and that will give you a solid platform on which to build your IoT applications. It includes essentially all of the wireless stacks and a lot of more functionality around that, a lot of middleware components. So it gives you both a breadth and depth of functionality that you can leverage for your application, so that you can really keep the focus of your development on the application while leveraging all the functionality that comes with the SDK. And both the host and the control stack for Bluetooth are 5.3 qualified since version 2.0.0. Let us then continue with the updates on Nordic development tools. So the first thing to talk about is the nRF util. There's a new version out, version 7.4.1. And two main things to highlight here. The first one is that there's a new built-in self-upgrade command. And what this command does is that it upgrades the nRF util core functionality to the latest version. So prior to this, if there was a new version of nRF util, you would have to go and grab the latest executable and overwrite the one you had. But from version 7.4.1 onward, this is no longer needed. You just need to run this self-upgrade command, and it takes care of upgrading itself without having to do it manually. One thing to notice, though, is that it doesn't upgrade the individual command. So if you have, for example, the device command installed, that's something that you need to upgrade separately from this self-upgrade. The other thing was that there's a new command that was introduced, nRF util trace, and it is used to analyze or monitor the modem traces from the nRF 9160. And with that, you can analyze traffic with Wireshark. Two options here. You can either pipe the traffic to the Wireshark executable and analyze the traffic live as it's coming from the nRF 9160, or you can just save that to a Wireshark file and analyze it at a later stage. You can also use that to create a file that can be uploaded to the online power profiler, and with that analyze the static power consumption of the nRF 9160. So this tool is quite useful if you're doing scripting or if you want to include it as part of your test automation framework. We have added a link to the documentation of the nRF util trace command directly if you go over there and click on that hyperlink. We have also introduced a new tool in nRF Connect for desktop. It's called the serial terminal. So this new serial terminal was built so that it can be used with other applications in nRF Connect for desktop. And what this means specifically is that it allows sharing the COM port data between the applications. So you can have the serial terminal application open and interacting with a kit with the shell, for example, and then you can have other applications which are also accessing that data for different purposes. It has line or shell mode, and it will also auto reconnect after device reset. Or, for example, if you pull the USB cable out of a kit and replug it back in, it will recognize that the device is reconnected, and it will automatically connect to that COM port. We are also very happy to announce that we are introducing beta releases of nRF Connect for VS Code extensions, and that is using the pre-release feature in VS Code. It's extremely easy to switch between the beta and the production versions of a given extension. If you go to the extensions on the VS Code itself, look for the extensions that have this icon here. So once you click on that, it will switch between the production and the pre-release beta version, depending which one you're using at a given moment. And once you do that, it will prompt you to reload VS Code. That takes only a few seconds. So, but this means that it's not disruptive to your development flow. So if you're of course working on your application and there's a pre-release of an extension, you can go and try that out and then revert back to the production version very easily. So that won't be impacting your development flow. And there's already something you can try today. We are introducing a new tool called the Device Tree Visual Editor. And that is something you can get as part of the pre-release of the Device Tree, nRF Device Tree extension. It is a graphical user interface, which very much resembles COD or a hardware design tool for schematics. And what this does, that it abstracts all the details from the device tree. So you don't need to sort of get into the device tree details, which, it can be a little bit difficult to get into. And there's a learning curve associated with that. So this is now an optional tool. It's not something that you must use. It's something you can use, and it will help you to leverage the device tree and build the model of your hardware, which you are developing on. It's not using any kind of special files under the hood. It just operates directly on the existing device tree and overlay files. And these are updated on the fly. So as you interact with the device tree visual editor, you can see the changes immediately on the device tree files and vice versa. If you go to the device tree files and you change some data there, you'll see the editor also changing accordingly. And yeah, so as mentioned, it is available today in the nRF Connect device tree extension from within VS Code. And yeah, let's now have a demo of this tool so you can have a better feel for what this can do for you. So for the device tree visual editor demo, I'll be using the pre-release version of nRF device tree extension. So we need to go here to the extensions, and then let's scroll down because I already have it installed. And you can see this button here. So if we see the extension page, it tells us that there's a pre-release version and we can switch to that pre-release. So clicking here or here does the same thing. So I'll just go and click on that, and it will install the pre-release and tell me that I need to reload Visual Studio Code, which is okay. So I click reload required, and it takes only a few seconds. So it's really, really fast. Okay, so we have now installed the pre-release, and we can go back to the production version, just pressing on the, clicking on the same button over there. Okay, so let me close this up, close this, and so I already have a project. I have a Blinky application, and it has a build target, the nRF 52840 DK, and I have created a overlay file, which is currently empty. So when you install this pre-release version of nRF device tree, you will see when you open an overlay file or a device tree file, you will see this new little icon here at the top. It has like it's a chip. And it will, the pop-up says show visual editor there on the tooltip. So if we click on that, we will bring up the device tree visual editor. So this is the new tool that the pre-release version of nRF device tree is introducing. So what we're seeing here is the root of the device tree. So on the top left, we have all the nodes in the device tree. Below that, we have the properties for a given node. And then on the right-hand side, we have the visual representation of that node. So let's look at a few of the things that we can do with this. For example, something that it's commonly required is to reassign, assign functions to certain pins. So we can see here that we have buttons defined in the device tree for the kit. Button 1, button 0. So let's try and just reassign this to a different pin. Let's say that we want to reassign a button 1 connection from P011 to P010. So we'll just click on P010. It brings us a pop-up with some properties, and then we can select the node that we want on that pin. So we could just scroll and say, okay, I want to have button 0 here. And as I click assign, we'll see that the button 0 will just kind of jump into that pin. There we go. And as we're doing this, it's also making a change to the device tree. It's doing that on the overlay file. And the reason why I'm using an overlay file is so that I don't modify the original device tree files from the kit in the SDK. So I'll just make the changes specific to my application using an overlay file. Okay, and as mentioned before the demo, this device tree visual editor is not using any kind of proprietary data format. It's just operating directly on the files. So let's actually do a bit of a split screen here so I can show you what that means in practice. Let's close this so we get a little bit more space like that. Okay, so yeah, let's say that we actually wanted to go back to pin 11. So we could just change that. So as you could see, it jumped straight back into P011. So this is literally a visual representation of the device tree. So it's an optional tool that will help you build out the model of your hardware, but it's optional to the method that you had before. And what this also means is that you can use this new tool with existing projects, with existing designs. We have tested this down to nRF Connect SDK version 1.7.0. So you can leverage the tool today on an existing design. If you want to make modifications to the device tree, this tool should really help you. So, changing pins, that's a simple use case. Let's try something a little bit more advanced. So very common peripheral to have on IoT devices is a sensor. So let's expand the SoC node and let's look for example, the I2C node here. So as we click on that, let's close the split screen. As we click on that, it shows us that we have the I2C node as a kind of a visual representation of that. Right now, it's just open. There's nothing connected to I2C. So let's try to add something there. So we click the plus there, and then it brings us a pop-up to add a node. And we have a list of options. So I will want to add, so these are the I2C sensors and devices which are supported in Zephyr. So let's say I want to add a BME 680, which is an environmental sensor. So we could just search. It will give us narrow down the options. Click on that. We could give it a name and sensor. So we could give it an address. I believe it's 70 hex, and then we do add. So now we have our environmental sensor connected to the I2C node. And then if I, not here, but if I right click here and select show and text editor, it will just jump into the portion of the device tree where this is being declared. So you can see that within the I2C node, we are adding a sensor which is compatible with the Bosch BME 680, and it already wrote the I2C address for that device. So this is just a very simple example of what you can do with the device tree visual editor. So this is now in pre-release mode. Do go ahead and try it out. If you have suggestions, if you find bugs, there's a very handy give feedback button on the top right over here. And again, you can always revert back to the production version of the extension so that it won't be disruptive to your development flow. So we hope that this is something that you'll find very useful on your development efforts with Nordic software. And now for updates on Bluetooth. So the first thing is that we added support for periodic advertising sync transfer. So what this feature allows is that the synchronization data for periodic advertising can be transferred over an ACL connection, which means that a device can receive the synchronization data without having to go through the synchronization process, which gives power saving benefits if you have an energy constrained device. And this feature is quite important for Auracast Assistant, which is typically something like a mobile phone or a remote to a hearing aid, so that the Auracast Assistant can transfer this synchronization data of whatever broadcast is being selected to the Auracast receiver, which will be your earbuds or a hearing aid device. We have also added experimental support for a new Bluetooth 5.4 feature called Periodic Advertisement with Responses. We added support for the advertiser role here. And the key thing is that this enables bidirectional exchange of application data with connectionless communication. So before this, using advertisement or connectionless communication was one way, and now this can be bidirectional. We have written a DevZone blog about Bluetooth 5.4, which includes description of periodic advertisement responses. So if this is something you're interested in, I recommend that you go and read that blog post. It's important to point out that the soft device controller is still Bluetooth 5.4 qualified. And we also have on Bluetooth LE Audio experimental support for public broadcast announcement and bidirectional streams to and from two headsets. Going into a little bit of details into some of these features. So the periodic advertising sync transfer, just trying to visualize what this means in practice. So if you have a device that is a periodic advertising transmitter, and you have then two devices that want to synchronize, without this feature, they would have to individually go through the synchronization process, which carries a penalty in terms of energy consumption, as it requires quite a bit of radio duty cycle. With this feature, with periodic advertising sync transfer, that information can be sent over a connection. So you would be here in a case that you have your periodic advertising sync transmitter, you have a device that has already synchronized, and you can just send the synchronization information to another device so that this device will then be able to receive the periodic advertisings from the transmitter. And so if you have a battery constrained device or a device that has any kind of energy constraints, this is an important feature, as you don't have to go through the synchronization process individually. So you kind of save that power penalty of having to go through the synchronization process, as you just receive the information from another device that has already synchronized. And within the Auracast, why this is important. So in Auracast, you will have a transmitter sending out these audio streams. That could be a television or a smartphone or let's say a PA system, for example, at a shopping center or an airport. So it's sending the audio streams and then it's sending the information about these different broadcasts. And then you'll have what's called the Auracast Assistant. So this would be a device that is not, particularly constrained in terms of power consumption. So typically this would be a smartphone, it could be a smartwatch, it could be a remote, like a device that has a display and a larger battery. And this will display information on all the available broadcast streams that it can pick up. And then the user would select which stream it wants to listen to, and it would use this periodic advertisement sync transfer feature to send the information into the Auracast receiver. And this would be your headphones or earbuds, hearing aid, that kind of devices that typically have small batteries. So you'd want to make sure that you save as much power as you possibly can to extend the battery lifetime of that device. Then on the periodic advertisement with responses, so the new Bluetooth 5.4 feature, essentially the biggest benefits of this feature is, as we mentioned already in the first slide, is that you now have bidirectional connectionless communication. So the devices can exchange data both ways in a connectionless fashion. And it supports a really, like the scale of this can be quite large. So for each access point, you can select support. You can support up to north of 7,000 devices that can communicate using this new mechanism. And the benefit this brings also on the device side is that it will be ultra low power, because these devices only need to receive or turn on the radio for very short periods of time, which allows them to save a lot of power and extend the battery life. The main use cases for this feature, so we have ESL, electronic shelf labels, and the other thing that Bluetooth 5.4 specification introduces is also a profile for ESL that builds on top of this feature. But you can also have other applications like sensor networks, where you have a bunch of sensors across a certain area, and you want to collect data and exchange data with these sensors. Smart locks for hotels or restaurant paging systems, classroom response systems, and other similar deployments where you require large scale with ultra low power on the device side, and you want to have this bidirectional connectionless communication. So how this works is that the data is sent by the advertiser in what is called periodic advertisement response events. And each of these events has sub-events. The observers can then synchronize to one or to multiple of these sub-events. And what this means is that then the synchronized observers really only need to scan for a really small and precise period of time. So that is the main difference between periodic advertisement and the legacy advertisement, which has jitter, so you need to scan all the time or be in RX mode all the time, which means there's high power consumption demand, versus periodic advertisement, where the advertisements are coming at very precise points in time. So these observers know exactly when they need to wake up and start doing RX to capture those advertisements. And then within these sub-events, there are dedicated slots for responses from each of the observers. So this is what enables this bidirectional connectionless data exchange between the devices. The response scheme, or how do you assign these responses to different observers, that is handled at the application level. So on the previous slide, I talked about that ESL has a profile that was introduced also with Bluetooth 5.4. So that profile describes the response scheme for ESL. So that is something that, if this is a feature that you want to leverage, you can look at the ESL profile and see how it's done there as a reference. And the other thing that's worth pointing out is that this feature also allows to establish a connection. So you can either broadcast data, or you can also send a connection request. So going back to the ESL example, let's say that you want to send, let's say, new pricing information to a certain tag or a group of tags, or some configuration data. So that's something that would benefit from a little bit higher throughput. So what you can do is that you connect to that tag using the periodic advertisement with responses, send that data quickly, and then close the connection. So you don't need to go back to the legacy advertisement that, again, is very costly from a power consumption standpoint. You can also use this feature to establish the connection, send the data, close the connection, and go back to the periodic advertisement for other data exchange purposes. So now we'll go over into updates on Matter. So one of the key value propositions of Matter is this interoperability between devices and also between ecosystems. And we know that this is something that customers are very interested in testing from day one when they get started with Matter. So we have released a blog post on DevZone, Matter testing the nRF Connect platform with Apple, Google, and Samsung ecosystems. You can find the link right here on this slide. And this blog post demonstrates how you can test the nRF Connect SDK Matter samples, both for Matter over Thread as well as Matter over Wi-Fi. So you can take those samples with the Nordic kits and test them with the Apple, Google, and Samsung SmartThing hubs, which connect to their own ecosystems. And it is the Matter multi-fabric feature that enables that. So the blog post discusses this feature and guides how you can share Matter devices between ecosystems. So if you're developing Matter products or you're interested in Matter, this is a really interesting read. And now, specific to the nRF Connect SDK version 2.3.0, we have improved the door lock sample. And what this means is that now it supports switching between Matter over Wi-Fi and Matter over Thread. So the reason why we have this solution now is because not all the Matter hubs out there support Matter over Thread. So if a customer buys a device that is Matter compliant, you may not have a hub that supports Matter over Thread. So this solution allows you to develop a product that can support both. So it can default as a Matter over Wi-Fi device. And if the customer later has a hub that supports Matter over Thread, they can switch to that and leverage the low power benefits of Matter over Thread. So this door lock sample, defaults as a Matter over Wi-Fi device. So this is running on the nRF 5340 DK with the nRF 7002 EK. For the Wi-Fi, and then there's an external flash that contains both the Matter over Wi-Fi as well as the Matter over Thread image. And so the door lock operation can be visualized with the LED 2 on the nRF 5340 DK. When the LED is on, it means that the door is locked. So it would mean that physically the bolt is extended. If the LED is off, so the door will be unlocked as if the bolt was retracted. And when the LED is flashing, it's moving between locked and unlocked positions. Then by pressing button 3 with a long press of over 3 seconds, it will trigger the switch. So what will happen is that MCU boot will retrieve the matter over thread image and write that into the nRF 5340. And then it can be added to the matter network as a matter over thread device. And let's now move on and show you an actual demo of this door lock sample in action.
Currently on the market, there are plenty of Matter ecosystem solutions and smart hubs. However, some of them support Wi-Fi transport only, without implementing thread border router functionality. Therefore, Matter over thread devices will not be operable in such a setup. To address this use case, in recent nRF Connect SDK 2.3, we implemented a feature which allows to switch the Matter device between Wi-Fi and thread networking modes. Depending on the chosen transport, the user can take advantage of either high throughput or low power operation to meet Matter flexibility foundations. To showcase our solution, here we have a Google Nest Mini, which controls the door lock application through Wi-Fi. We can interact with the lock by using Google voice commands. Hey Google, unlock my door lock.
Sure, unlocking the door lock.
Hey Google, lock my door lock.
Got it, locking the door lock.
Now let's assume a user has also a Google Nest Hub second, which supports thread transport, and they would like to move the Matter device to the thread network. Now let's switch door lock device into thread transport mode. To do so, I need to press and hold the button 3 on the nRF 53DK, which by the way has nRF 7002EK attached to implement Wi-Fi radio. It's worth mentioning that Product Maker is able to modify the switching procedure, for example by using mobile phone and proprietary Bluetooth Low Energy service. Now we need to wait for the application image to be swapped with Matter over thread application. The swapping procedure is completed. Our door lock now needs to be provided with thread credentials. Therefore, I'm going to commission the device to the thread network with Google Home app. Let's start Bluetooth Low Energy advertising with button 4 and then use pairing code which is available in the Nordic Matter door lock sample documentation. Once the commissioning process is completed, we have a device attached to the thread network and we can control the door lock with Google voice commands. Hey Google, unlock my door lock.
Got it, unlocking the door lock.
Now for updates on Wi-Fi, the newest technology in Nordic's product portfolio. So the nRF 7002 Wi-Fi 6 companion IC that was recently launched. Now we have support on nRF Connect SDK. That is the main update, but there are also some updates on the Wi-Fi samples. So the provisioning service sample has been improved. And the improvement is that the provisioning Bluetooth CAT service is now available as a library. So in the previous version of nRF Connect SDK, it was done at the application level within the sample itself. But now that's been refactored and it's available as a library. And what this means is that if you're working on a Wi-Fi application and you want to leverage this Bluetooth GAT Wi-Fi provisioning service, you can more easily add that by having it available as a library that can easily pull into any application. Then there are two new samples, one demonstrating Bluetooth LE coexistence. So that is the coexistence between the Wi-Fi and the Bluetooth radios to avoid collisions and make sure they can share the airtime. And there's also a new MQTT sample that demonstrates connecting to a broker for publishing and subscribing to messages. This MQTT sample actually supports either cellular or Wi-Fi. It depends on the build target that you select to build a sample. And I think this one is actually a really good example of what you can get with nRF Connect SDK modularity. So you can see that there's a single application code, and that can leverage different wireless connectivity mechanisms, just depending on which kind of target hardware you're aiming to build this sample for. So now we have a demo on the nRF 7002 Wi-Fi 6 companion IC. So before we get going with our demo, let's have a quick look at the hardware setup that we will be using. So we have here the nRF 7002 DK, and we have here the PPK2 or PAwR Profiler Kit 2. And they are connected together. And this connection here is simply following the documentation for the nRF 70 series. So there is a section for PAwR profiling. So what it instructs us to do is to remove the jumper on connector P23, which is the one here at the top. And then we need to connect the PPK2 to ground on the board. So we're going to be using pin 1 on P21 down here, so the one with the minus label. And then we're going to connect V out, which is this brown wire, from the PPK2 into pin 1 of P23, where we took out the jumper from. Then on the PAwR Profiler application, which controls the PPK2, we're going to configure it as a source meter, supplying 3.6 volts into the board. And this connection here is actually going to supply the Wi-Fi circuitry, so the nRF 70 device, which is on this board directly. And with that, we can measure the current consumption that the PPK2 is supplying to the board. And to show you exactly where the piece of documentation is, so I'm here on the main page of nRF Connect SDK. We're in version 2.3.0. So we're going to go down to working with nRF 70 series, clicking on that. So we expand the subsections, and then developing with nRF 70 series, and then operating in PAwR save modes. And towards the end of this section, we have PAwR profiling. So as you can see, this one here is the diagram which represents the hardware setup that I just showed. So now we can move on to our demo. For the demo, I have flashed the Wi-Fi shell sample from nRF Connect SDK version 2.3.0. And I'm using the serial terminal application that was recently introduced into nRF Connect for Desktop. So this application allows me to interact with the kit through the command prompt. And on the right-hand side over here, I have the PAwR Profiler application, which can also be found in nRF Connect for Desktop. And this one is used to interact with the PPK2. So as mentioned during the hardware setup overview, we have configured the PPK2 as a source meter, and we are supplying 3.6 volts to the target. Let's start by issuing a simple Wi-Fi status command. So right now the Wi-Fi device is not connected, it's not scanning. So let's start sampling the power consumption. And if we hold shift and scroll across the section here, we get a sample, and we can see that the average power consumption at this point is 13.44 microamps. So let's go ahead and connect to our access point. So we issue the command Wi-Fi connect, then the SSID of the access point, which is Nordic, and then I have configured an easy password just for demo effect. So let's send this over. And the access point that I'm using is a Google Nest Wi-Fi Pro, which is a Wi-Fi 6 enabled device. Okay, we have associated with the access point, so we're now connected, and we can see that the power profiling signature has changed. And if I take a sample here, we are now at 55.37 milliamps. It is quite high, and of course not suitable for energy constrained or battery operated devices. And the reason is that we don't have any kind of power saving mechanisms enabled right now. So that's what we'll do next. We will enable power save. So we'll send Wi-Fi PS on, and this will enable what is commonly called as legacy power save or DTIM. And we can see when we send the command that the power profiling signature changes quite significantly. So the station and the access points seem to be interacting with each other at some regular intervals, and in between the Wi-Fi can go into a low power mode. So let me stop sampling for a little while, and let's zoom in, and we can measure this DTIM period. If I just hold shift and scroll across, so it's about 200 milliseconds, and in between those DTIM, we have 11.59 microamps power consumption. Let's zoom out and take a longer sample so we can have an idea of what the average power consumption is. And we're now at 888.41 microamps. So this is a very large improvement compared to the 55-ish milliamps we had without any kind of power save enabled. So next we're going to enable target wait time. Let me go back into sampling. There we go. So one of the downsides of DTIM is that the access point decides the DTIM interval. So in this case, it was 200 milliseconds, but it could have been 100 milliseconds. And in that case, it would, of course, have an impact on the average power consumption on the Wi-Fi device side. So let's now enable target wait time. So we need to send this command over here. And we are requesting target wait time of 10 seconds. So this here is in milliseconds, so 10,000 milliseconds. And the benefit of target wait time, which is a Wi-Fi 6 feature compared with the DTIM, is that the station can request a specific number. That, of course, allows a level of control that it's not possible to have with the legacy power save. So let's go and send this command, and let's see what happens on the power profiling side. Okay, so it seems that our device can spend a lot more time in low power mode, which is exactly what we were looking for. And now the device and the access point are interacting at still at regular intervals, but at 10-second intervals. So that was the request that the station made to the access point. So we had the first one over here, and then the second one, and let's see if we can wait and capture the third one as well before we okay, there we go. So let's go ahead and measure this. So hold shift and scroll across. So now we can see it's 10 seconds. And if we want to see the impact on a average power consumption, so now we have taken even another step improvement compared to legacy power save, and we're now at a 200 microamp average power consumption level. Which is something that a battery power device could already be a suitable level if you're implementing an energy constrained device or a battery power device. Okay, so this concludes our demo on the nRF 7002 Wi-Fi 6 companion IC. Okay, so before we move on, just to highlight that if you are interested in Wi-Fi, you can sign up for our Wi-Fi newsletter. And we recently also had a webinar, Introduction to Low Power Wi-Fi, which is available on demand. So if you are thinking about developing applications with Wi-Fi, then I strongly recommend that you go and watch that webinar. And now for the last topic of today's webinar, updates on cellular IoT. So just a brief overview of the nRF Connect SDK for Cellular IoT. So on the left-hand side, we have here a block diagram of the nRF 9160 SIP, which contains, its own PMIC, passives and crystal, RF front end, as well as application processor based on the Cortex M33 with trust zone, its own RAM and flash resources, as well as peripherals. And then the modem side contains all the functionality required for the cellular connectivity. So basically, you only really need to add battery or any other kind of power supply to the SIP. Typically, you'll have sensors interfacing through I2C, SPI, communication interfaces, and then a SIM card, and you are off to start your application. And it supports LTE-M, NB-IoT, and GNSS as well. On the software side of things, we have the modem firmware running on the modem core. So that includes everything from the L1 to L3 layers all the way to TLS and DTLS. And the modem firmware is available on our website as a pre-built binary. And then within nRF Connect SDK, you have the modem library and then the functionalities that build on top of that. So you'll have your networking transports, MQTT, lightweight machine-to-machine, co-op. And then on top of that, you'll have other libraries and modules, for example, for connectivity to different cloud platforms, nRF Cloud, AWS, Azure, and so on. And then your application will be leveraging all of this rich functionality to do what your product really needs. So in the nRF Connect SDK version 2.3.0, we have made improvements within the locationing. So what you can do now is that the neighbor cell measurements and the Wi-Fi scan results can be combined into a single request to the cloud. So you can take the locationing data from both the cellular side and the Wi-Fi side, put them together, send them over to the cloud. Then on the cloud side, what happens is that the probability of having accuracy and reliable results increases. So it makes sense. You have more data, of course, then you increase the probability of having higher accuracy and more reliable results for the location that you get back from the cloud side. This is now supported in the location library, and it's being demonstrated in the Asset Tracker v2 application, as well as the modem shell and lightweight machine-to-machine client samples. And we have this running on a combination of the nRF 9160 DK together with the nRF 7002 EK. We have also added support to write the modem traces to flash, so you can store the modem traces to flash so that you can later retrieve them and analyze them if you happen to have an issue. So this is especially useful to have in the field, so you can analyze if there's some kind of misbehavior on field devices. So prior to this, there was support for UART and RTT backends. So now you have the external flash backend as an additional option. And the nRF 9160 modem shell sample now also demonstrates how you can store and then later update the modem traces to memfault. So once they're then in memfault, you can go to the memfault platform, download the traces, and then use the cellular monitor application in nRF Connect for desktop to convert them to Wireshark file format, and then use Wireshark to actually analyze the traces and look for any kind of misbehavior on those traces. And we also have a new sample that demonstrates how to use AT commands from a nRF 53 series or any nRF 52 series host device. So this would be using the Serial LTE modem application on the nRF 9160, which essentially bypasses AT commands from the modem into the UART, which is sometimes sort of the traditional approach to developing cellular products. So now you can check how to do this using a nRF 53 or nRF 52 series host using the Serial LTE modem application on the nRF 9160 side. And we have also added NIDD, which is non-IP data delivery sample, to demonstrate how that can be achieved. However, support for this feature is rather limited at this point in time from the network operator side. So if this is something that you're interested in using, do check the supports for the regions where you want to deploy your product, whether this feature is supported or not on the operator side of the link. And to close then on cellular, so the latest nRF 9160 modem firmware version is version 1.3.4. You have a direct link here, and it is compatible with nRF Connect SDK versions 2.1 up to 2.3.0. Also a link to this compatibility matrix and a link to the nRF 9160 certification webpage. And this now concludes the cellular portion of the webinar. And before moving over to the Q&A, I would just like to encourage everyone to sign up for the webinar so that you get email notifications when we have new webinars coming up when they're open for registrations. You can do that at webinars.nordicsemi.com. As we already, in the introduction, we talked about the Dev Academy. So those are interactive online courses, and you can find them at academy.nordicsemi.com. If you need support with your application development, so our tech support team will help you out through the dev zone. So that's at devzone.nordicsemi.com. And of course, for more generic information about Nordic's products or services, you can always head out to our corporate website at nordicsemi.com. And let's then move over to the Q&A and take some of the questions that came in during the webinar. All right. Thank you, everyone who attended today. So we had a few questions coming in. Let me start picking those up. So there were two questions about the device tree visual editor. One was whether it's available for nRF 9160 and also whether it supports creating a board from scratch if you have a custom board. So the answer is yes to both, or more generically, the device tree visual editor, it simply operates on existing device tree files. So it is a literally representation, a graphical representation of the device tree files. So you can even use it with existing projects on older SDK versions, and it supports all the hardware that is in the nRF Connect SDK. So it's a great tool in the sense that you can use it if you want to. It's a great assistant to create a device tree. But you don't have to be tied to it. You can always go back to the text edit mode of the device tree file. There was a question about Dev Academy, whether we're going to have new courses. So yes, we'll have new courses, but we can't really comment on content or timing. Then there was one saying that there was an Onomondo webinar where they said that the soft SIM was included in the nRF Connect SDK 2.3.0. This might have been a misunderstanding. Maybe it was meant that it's compatible and not included, because this is distributed. The SoftSim library is distributed by Onomondo. It's not distributed by Nordic. And a question about the periodic advertisement with responses, whether there is samples in the SDK, not at this time. And also keep in mind that only the advertiser role is supported at this point, and it's supported using the HCI interface. And ETA question, ETA for nRF 7002 Soft API Direct, Wi-Fi Direct. So we don't comment on roadmap on these webinars. If you want to know more about these dates, I encourage you to reach out to your local RSM, so your local or regional sales manager. And then still kind of on the roadmap topic about the officialization of Bluetooth Mesh Profile 1.1.0. There is no public information, and this is within the domain of the Bluetooth SIG, so it's not something we can comment on either. And just a second, there's a few more questions that came in. So Matter device is fully supported by Google Home. Yeah, so Google ecosystem supports the Matter 1.0 specification. And what is the approximate per consumption of the clients in Bluetooth LE PAwR periodic advertisement with response? I can't really give a figure because this is configurable, right? It depends how many sub-events synchronized to, how much data is sent. So there's a lot of variation there. One fact is that it can be extremely low power. It can be a little bit less low power depending on how much data you want to send. So it depends, I think, is the answer here. You'll have to implement what the requirements are for your application and see what you can get with that. Can I use self-sim with nRF 9160 and modem firmware 1.3.4? I actually don't know for sure, but if it's compatible with the nRF Connect SDK 2.3.0, then I'm guessing the answer is yes. But this is something I would maybe encourage to ask on DevZone to be 100% sure. Is Matter in nRF Connect SDK production ready? Matter over Thread is supported, so it is production ready. Matter over Wi-Fi is experimental, but it will soon go into supported state as well. Okay, it seems that I've answered all the questions. So stay with us for a little second. I will just put a poll asking about the webinar. Okay, I hope you can see this. I'm just adding a poll for you guys to rate the webinar content. And I'm going to add a second poll asking about the demo. So you can, if you could answer those separately. And there we go. Oh, seems that okay. So I need to wait for the votes to come in on the first poll before I can open the second poll. So could you guys put something on the chat to acknowledge that you're seeing the first poll? It should be visible. I'll put it here on video. Okay, a few more questions came in, so let's see if we can get those. Yeah, so good point. So 1 would be the lower end of the scale, and 5 would be the high end of the scale for this poll. Okay, I guess I will then close the poll. We got 30 votes in, 31. I'll give it 10 more seconds, and then I'll open the second poll. All right, so let's close that one. Yes, and let's start the second poll. Just play that now on the video. So this is now about the demo specifically. So the 3 demos that we had on the device tree visual editor, on the nRF 7002 Wi-Fi 6 companion IC, and then on the on Matter, switching from Matter over Wi-Fi to Matter over Thread. I'm hoping you guys can see the poll. Takes a little while for the results to come in. There's a question, were there improvements to Kconfig in 2.3.0? So one thing that is worth mentioning is that so the nRF Connect SDK and Visual Studio Code extensions, they're not part of the same release as such. Actually, we haven't yet released a new version of these extensions other than the pre-release of the nRF device tree. So I don't exactly know what extensions will be updated and when. but we try to basically cover those two things together in the same webinar, because we have the nRF Connect webinar after each release, and typically the tools are released a few weeks before, or a few weeks after in worst case. We try to cover the improvements that we know are there, but what's coming after we can't really comment. So this is more on the roadmap side of things. Okay, so we got the poll in for the webinar demos, and I'm going to close that as well. Okay, so I think that we tackled all the questions. I don't see any more questions coming in. So thank you everyone for attending the webinar. Yeah, do subscribe to webinars to get email notifications when we have new webinars coming. And of course, we hope you continue joining these SDK webinars to learn about all the new features that we are bringing out with the new versions. All right, thank you everyone. Have a good morning, evening, wherever you are. Bye. All right. Okay, thank you to all of you who attended the webinar today. We only have a handful of questions. So before I go ahead and answer those, I just wanted to launch two very quick polls. So here's one: if you could rate the webinar content, 1 to 5, 1 being worst, 5 being best. I'm going to let this one hang for about 30 seconds or so. And then I'll open the other one. A few more questions coming in as I have the polls open. I'm going to now close the poll. We have 23 votes in. All right, and I will open the second poll, and I would like you guys to rate the demos, and let's give it 30 to 45 seconds as well. Okay. I'll close the poll for this one as well. All right, thank you for answering those polls. Okay, so let's take the questions that came in. Oh, let me just take out, there we go. Take out the poll from the screen. All right, so first question, is encrypted advertising from the Bluetooth Low Energy Spec 5.4 supported in the nRF Connect 2.3.0? And the answer is no, it's not yet supported. Then we have standardized on Android Studio instead of VS Code. Could you please make your plugin available for Android Studio? We don't have plans to do this, but Android Studio is for mobile app development. I'm not exactly sure how that's used for embedded development, if at all. So, but anyway, VS Code is our main platform that we're using as an IDE, as a development tool. So that is the solution that we have today. Then will the new overlay editor, so the device tree visual editor, be able to change pins defines or pin control files like UART and SPI? Yes, this is supported in the beta version that you can try out today. It's out, as I mentioned during the webinar. And then we have a
Professor of Computer Science asking for contact the technical team. I mean, DevZone is for technical contact if you're asking for support. If it's beyond that, then the regional sales manager. So you can if you go to nordicsemi.com, there's a contacts tab, and there you can put a question to the sales team, and it will be forwarded to the right person in your region. Then a question about nRF 9160 performance in terms of power consumption compared to the new Sony Altair chipset and partner modules. So I don't have numbers on this. This is something that can probably be extracted from the documentation for both parts. It's not something that I can do right now, but I would recommend to look at the data sheets for both parts. And if you need support, interpreting the figures, or if you need any additional information, then DevZone would be the place to go. Any runtime performance impact when writing modem logs to Flash? Good question. I don't actually know the answer to this, so I would recommend that you post this question to DevZone, where our tech support team can look into this topic. Is there a sample that demonstrates periodic advertisement with responses? Not on nRF Connect SDK 2.3.0, but at the moment this is enabled through a HCI interface. So there is no sample that shows that. And then what OS is running on the 7000 Intu, so the Wi-Fi computer and IC platform. So the Wi-Fi IC is running the lower MAC. It's essentially a transceiver. And then the upper stack, the upper MAC stack, and everything above that is running on a host device. It's running on if you have the 7000 Intu DK, you have the Wi-Fi chip, and then you have the 5340 as the host, and that is running Zephyr OS, just like all the other samples in nRF Connect SDK. Let me see. I think another question came in. RTOS is still Zephyr. Yes, RTOS is still Zephyr in nRF Connect SDK. And I think that is then the last question. So if no more questions coming in, thank you all for attending, and have a rest of a great day or evening, depending where you are. All right. Thank you. Bye.